Wet bulb temperature is an important concept to understand how some condensers leverage evaporative cooling to reject heat to the atmosphere. The wet bulb temperature is a measure of the lowest temperature that can be achieved through the evaporation of water into the air, assuming constant pressure. Put another way, wet bulb temperature includes the combined effect of temperature and humidity on the cooling potential of the air. It is a critical parameter in evaporative condenser and cooling tower design and operation. The word temperature is most often used as a shorthand to describe dry bulb temperature, which is the ambient air temperature measured with a standard thermometer. Wet bulb temperature, on the other hand, is measured using a thermometer with its bulb covered by a wet cloth with water evaporating from the cloth to cool the thermometer.
When I explain wet bulb to someone, I like to do it like this. Get your fingers and lick them, okay? And then just blow air out of your mouth out of your fingers. And you'll feel a cold sensation. Wet bulb, that is wet bulb. That is the wet bulb temperature. That's the simplest way to explain it to someone. The other thing you could do, imagine, you could do this in your mind's eye, but imagine it's a hot summer day and you go for a workout, okay? You get yourself sweaty, and then you jump in your truck to drive home. You roll down the window so the air can blow over your skin. Why do you do that? Oh, it cools you down. Why is it cooling you down? Well, because it's the wet bulb temperature. The air is evaporating, which is creating a lower temperature in your skin, which is the wet bulb temperature. Okay. Final example, I like to do this with my kids at home. We have a swimming pool, hot summer day, San Joaquin Valley of California. And even sometimes the pool gets hot where it feels like a warm bathtub, right? It's like 80, 85 degrees in the pool, but we have a box fan on our deck. So they jump in the pool and immediately, while they're all wet, go get in front of that box fan, they'll still get a very cold sensation. Why is that? Well, that water's evaporating off their skin, and the temperature in the skin is getting lowered, which is the wet bulb temperature. So those are 3 different ways you can think about wet bulb in a everyday sort of way.
Wet bulb temperature can be measured as follows. 1. Wrap the bulb of a thermometer in a moistened cloth to facilitate evaporation. 2. Circulate air around the thermometer to promote evaporation. This is typically done using a sling psychrometer, which one thermometer measures the dry bulb temperature and the other measures the wet bulb temperature. 3. As water evaporates from the cloth, it absorbs heat from the surrounding air and the thermometer bulb, lowering the measured temperature. 4. The rate of evaporation, and thus the difference between dry bulb and wet bulb temperatures, depends on the relative humidity of the air. Lower humidity allows for more evaporation, leading to a greater temperature difference. In very humid conditions, the wet bulb temperature approaches the dry bulb temperature.
So in this video, I get to pull out a super cool tool called a sling psychrometer and demonstrate how it's used and what it's for. So a sling psychrometer is a tool used to measure the wet bulb temperature. Wet bulb temperature is a measurement of the moisture content in the air, or wet bulb is used to measure the moisture content in the air. When we compare the wet bulb temperature and our standard air temperature, which is in engineering talk called dry bulb temperature, we can calculate what the relative humidity is. And we care about the relative humidity because that affects our human comfort. That tells us how, when it's really humid outside, it doesn't feel so good. But when it's less humid, when the air is drier, there's more opportunity for evaporative cooling, etc. This also pertains to condensers, especially evaporative condensers, because we're using the evaporative cooling effect. So when in an evaporative condenser, so when the wet bulb temperature is high, an evaporative condenser is going to have to work a lot harder. It won't be as effective. And when the wet bulb temperature is lower, an evaporative condenser performs wonderfully. All right. And another kind of fun fact is that as wet bulb and dry bulb align, when they become the same value, that's when we have 100% relative humidity. So how does a wet bulb work? Well, on this thermometer here, this is connected to a chain, which you're going to see how I use this in a second. But there's 2 thermometers. One's our standard thermometer, and it's reading 72 degrees. The other has a small piece of cloth wrapped around the end like a wick. And I'm about to dip that into the water. But right now, these 2 thermometers are recording the exact same temperature. It's about 72 degrees in this room. But I'm going to dip it in, and this one's extended further. So only the wicked thermometer gets wet. Okay, now I'm going to pull it out. So that's wet. It's fully saturated with water. I'm going to sling this thing. Now what's happening as this spins around and around and around is the water on the wetted surface, some of it is evaporating. And as water is evaporating, it is cooling the surface of that thermometer. And we know that as it cools it's going to lower the temperature. So what's going to happen once I've done this for about 30 seconds is I'm going to read both of the thermometers. And instead of them being the same at 72, the wet bulb thermometer, the one with the wick on it, will be a lower temperature. The dry bulb thermometer, the one without the wick, will be at the same temperature. It shouldn't change just from moving it through the air. If it does, only slightly. All right, let me give it about 10 more seconds, and then we'll look at these temperatures together. All right, that should be about good. Now, yeah, sure enough, 70 degrees, and now we're at 60 degrees. We're at 60 degrees now on our wet bulb. So we're 10 degrees spread. So now I can get my my trusty little slide rule here, which will tell me what my relative humidity is by aligning these numbers. So my wet bulb's 60, my dry bulb's about 72. That tells me my relative humidity is about 48 or 49%. So that's a demonstration of how a sling psychrometer works.
The wet bulb temperature is significant for several reasons. First, wet bulb temperature directly indicates the moisture content in the air. The smaller the difference between dry bulb and wet bulb temperatures, the higher the relative humidity. Second, wet bulb temperature is crucial in assessing the efficiency of evaporative cooling systems because it defines the lowest possible temperature such systems can achieve. Third, wet bulb temperature is a factor in determining human thermal comfort as it reflects the combined effects of heat and humidity on the body's ability to cool itself through sweat evaporation. Fourth, in weather forecasting, wet bulb temperature helps assess potential dew point and condensation levels, which are important for predicting fog, dew, and precipitation. Finally, high wet bulb temperatures can be dangerous or even life-threatening as the human body loses its ability to cool itself through sweating. Wet bulb temperature is a key factor in selecting and assessing evaporative condensers. This is because the wet bulb temperature is the lowest possible temperature that the water will achieve on a condensing coil. The second law of thermodynamics teaches us that heat always flows from a higher temperature to a lower temperature. So the lower we can make the temperature at the condensing coil, the more effective the heat rejection will be. Put another way, the design wet bulb temperature is directly related to the design condensing temperature. As the wet bulb temperature increases, the compressor must work harder to raise the temperature and pressure of the vapor so that the heat can be rejected.